Good afternoon, everybody. Thank you for being here at the Public Summit Sector in Brussels. My name is Sébastien Stormac. I'm actually born and raised in Brussels, so it's great for once to do a talk in my home city. That does not happen quite frequently. I'm living in London. I'm part of the AWS Tech Evangelist team with my colleague Javier that was talking here just before me. So different type of accent this afternoon. Spanish first, French accent, no. We are going to talk about containers, and we are going to talk about best practice, how to deploy containers inside the cloud. I'm going to do a demo of ECS, Elastic Cluster Service, Fargate. We are going to see different techniques that you can use to really deploy your containers at scale this afternoon. You can reach out to me on Twitter on Sebsto, Sébastien Stormac, S-E-B-S-T-O, if you want to give feedback about this presentation, if you think I'm too slow, too fast, speaking too slow, speaking too fast, if I need to go deeper for next sessions, let me know. This talk will be loosely structured around something called the 12-factor application. Anybody knows 12-factor app? 1, 2, 3, 4, 5, not that much actually. It's a set of recommendations, of best practice, how to deploy architecture, how to deploy application, how to create scalable, highly resilient architecture in general. So there are 12 different factors, like many good things in life. They are going by 12, the 12 months, the 12 dwarf, or the 12 fingers of the hand. I'm not going to go through all that list because it's a long list, you know, it will be like factor 1, factor 2, but I will loosely use this as a red line during the rest of this talk. So, one of the principles of 12-factor application is to have a clear separation between your code that you want to run and the underlying operating systems, the other underlying platform where you are going to run that code, and of course to run a good 12-factor app, Dockers and containers is probably the best way to separate your concern between the application on one side and the platform on the other side. We have a couple of services on AWS that can help you to actually run your Docker container at scale in the cloud. Maybe you heard about Elastic Cluster Services, ECS, or Fargate. I'm going to talk about that and to demo this service a bit later in this presentation. But what's the challenge here? Maybe you are running Docker already. I guess most of you know about Docker if you are here. And running container, it's pretty easy. You just type docker run and voila, you have your container. Running your container in the cloud is not different. You just start a couple of EC2 instances, you install Docker on this instance, and then you start your container on this instance. What can be wrong with that? Many things, actually. Many things can go wrong. What about scalability? What about high availability? Who is going to check when container is running, when your container is not running? Who is going to replace failing container? Because remember, everything fails all the time, so you need to design your application in such a way that it will be resilient and that failed component can be restarted. What about scalability? If you have peak of traffic, you will need more EC2 instance, you will need more containers. And that's why we have introduced 2 years ago, I think, maybe a bit more, ECS, Elastic Cluster Service. So Elastic Cluster Service is a managed service in the cloud that will run a cluster for you. So it will take care of the elasticity of the cluster, adding more instances to the cluster, reducing the number of instances in the cluster. It will take care of the health of your container by pinging your container to be sure that actually they are healthy, and it will replace automatically failing containers. So it will kill containers that are not replying to the ping or replying with an error message and restart them automatically. It will also deal with the load balancer with you. I'm going to go into more details in a minute. So ECS manage your cluster at scale in the cloud. And if you look at one EC2 instance, to make that happen, there is no magic. We need a bit of software. We need an agent. So inside every single EC2 instance, which is installed, part of your cluster, we need to have an ECS agent that listens from the order coming from the cluster manager, from the placement, some piece of software that can start your container, that can restart your container, that can kill your container. We do provide these pre-installed in an Amazon machine image, AMI. It's a pre-installed configuration, operating system image or disk image that you can use to boot your EC2 instance from. So you do not need to manage that by yourself. But still, you see this EC2 instance, you need to place this EC2 instance into a network. You are responsible of maintaining these EC2 instance as soon as they are started. Maybe you heard already about the shared responsibility model. We take care of the security of the cloud. You take care of everything you run in the cloud. So as soon as the EC2 instance is started, it's your responsibility to manage that instance on the long term, to patch it, maybe to patch operating system vulnerabilities, for example. And that's still quite a lot of job to do at large scale if you have dozens, hundreds of EC2 instances running. So what if we can just get rid of the EC2 instance? What if you can just give us containers and tell, hey, Mr. AWS, please run these containers in that network, in that availability zone, without you having to manage EC2 instance. And that's Fargate. Fargate, it's a managed service, a serverless service to run your container without running an EC2 instance. When I say without running an EC2 instance, yeah, under the hood, underneath, yes, there are still EC2 instances. There is no magic. Your containers are not running somewhere in the air, but it's totally hidden from you. These instances are not managed by you. They are not appearing in your EC2 console. You don't see them. You are not charged for these EC2 instances. We bill you per unit of minutes of the CPU running for the container itself, but not for the EC2 instance. So it's Docker without virtual machines. You just tell us, hey, run 10 Docker instances across these two availability zones in that network, and we do all the magic under the scene to start this EC2 instance, to scale this EC2 instance, to patch this EC2 instance. So that's Docker without any server. One of the first best practice if you're deploying Docker container or containerized container application inside the cloud is to group everything inside source code control. You are probably using Git. If you have white hair like me, maybe you remember things like Subversion or CVS before that. Git is the central repository where all your artifacts must live. And not only the code of your application, but also the configuration, also the script to create the execution environment. I'm going to talk about that a bit later. It really must contain everything that allows you to deploy a running application. Not only it's better if you are working in teams to know who changed what and when and to be able to revert back, but it's also a perfect image of your system. And when I say system, it's not only your application, but it's also the infrastructure. You can run any type of Git, of course. At Amazon, we have AWS Code Commit. Code Commit is a managed service to run at large scale a Git server for your team. So it's secure with IAM and with SSH key. There's the same IAM that you love and that you learn to use from the last 10 years maybe on AWS. But it's running without server, without backup to maintain, without operating system to maintain on your side. It's a serverless Git service running in the cloud. Second best practice I would like to go through, it's how do you manage your dependencies? You know that when you are writing an application today, most of the code is coming from dependencies. Actually, you focus on your business code, but most of the infrastructure code, most of the common things are coming from libraries that you are downloading. Beware of these libraries, because when you use libraries and you use package manager, for example, to download the latest version of libraries, like npm, yarn, or pip maybe on Python, these package manager are by default downloading the latest version of the libraries. Latest version means from one day to the other, you're going to build your application, and the dependencies will change according to the roadmap of a third party that you don't know about. So when you're using libraries like files like package.json in Node.js, in JavaScript, or requirement.txt in Python, always use version number so that you can repeat the build process. It's very important that every time you build your application, you are confident about what are the bits and bytes that change and what did not change. And you want, of course, to minimize the number of change over there. So always use a version number to ensure that you're going to download that specific version from the cloud and not just the latest version that happened to be released. Maybe that is buggy, or maybe that has some other security issue maybe that you don't want to include inside your application. That's also valid for your Docker file. So when you install, when you build a Docker container, you have that command run apk add. In that case, it's an Ubuntu image. And actually, that one is not going with my best practice, because this one install make GCC, G++, Python without specifying any version. So every time I'm going to build a container there, I will get a different container, which is not exactly what I want. That's exactly the opposite of what we want with containers. We want containers to be stable over time. So always add a version number when you add dependencies. Next step about configuration. I remember when I was a consultant last century, I was working in a bank in a project, and the configuration was inside the zip file that we ship to the operation team. So in the operation document, we tell the guy, say, hey, unzip the file, replace that file in that directory, build your zip again, and then you have a zip that you can deploy into production. It was a jar file, if I remember well at the time, Java. You know how jar files are sensitive to directories. If the operation person made a typo when building the zip again, then the production deployment would be totally broken. And the binary that we ship to production, test, and development was not the same, because we had to unzip, change a file, rezip. Never, 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 never do that. I somehow managed to survive that. I'm still here today. But the best practice here is to separate the environment, the configuration, from the code. So the code is always the same. It's your Docker container. Do not include any configuration inside the Docker container. If you have URLs for your database, or if you have secrets, just separate that. So the configuration can be on the runtime systems, like production, development, test, and the container is just the binary, and the container runtime will pick up the configuration from the environment. So I have some nice graphic to explain what I just explained, but yeah, you get the idea. The configuration is on the server side, and the container just dynamically fetch the configuration. How can you do that? Environment variable, it's a very easy way to program. You can refer to environment variable from JavaScript, for example, with process.env, the name of the variable. You can test that easily on your laptop, simulating environment variable with the -e command line on Docker. And of course, if you're running in the cloud, you need to tell us what is the environment. So on ECS and Fargate, we have that concept of task definition. And a task definition, it's the list of environment variable and your Docker container. So a task definition is really the unit that you're going to ship to one specific environment. I'm always a bit nervous when I see secrets or passwords in environment variable. That's probably not a very good practice. On AWS, we have a service called Secret Manager. And Secret Manager, as the name implies, is there to manage your secrets. So you can define in that service your list of passwords, maybe per environment. You can, of course, cipher these passwords. You can apply a key rotation to these secrets. And at runtime, any application can use the Secret Manager API to securely retrieve the secrets, of course, if it has the correct IAM permission. We integrate Secret Manager with ECS, so if you are running Docker container, typically in a task definition, you pass us the environment variable. You are not obliged to put a password in this environment variable. You can just refer to Secret Manager, telling the cluster, hey, that environment variable, you put the name, will take the value from that specific secret in Secret Manager. And at runtime, the cluster will query Secret Manager, fetch your password, and pass that as an environment variable to your Docker container. It allows to keep all your secret and password per environment in a secure and controlled environment called AWS Secret Manager. Do I still have everyone with me there? I'm progressing in my list. Backing services, dependencies, dependencies between services. You know that typically a microservice 1 calling a microservice 2 should never call the service directly, because that microservice 2 might change location, change IP address. Maybe you have multiple microservice 2 to scale, and depends on the load, you might have really a lot of these. So how do you refer to them? Best practice is always go through two things. First, a DNS name, never hard-code IP address. IP addresses are not stable in the cloud by definition. We are adding IP address and removing IP address. And always go through a load balancer, because today maybe you have one instance of your microservice, but tomorrow you will have 2, 3, 4, depending on the scale of your application. So always go through load balancer and refer to them through a DNS name. You can do that manually and register a new version of your container to DNS, but we have a service that helps to do that as well. It's called AWS Cloud Map. And the idea of Cloud Map is to run a registry, a repository of your runtime service in the cloud. So the cluster knows that and does that by default. So if you start a container in ECS and you register Cloud Map, the cluster will register the instance of your new container to Cloud Map, saying, hey, version 3 of that service is now available at that IP address. And in Cloud Map, you define the definition of the service, you define a name for your service, and you define how client of that service wants to query that service. We have 3 different ways to query. The first one is to use the Cloud Map API. So microservice 1 can call Cloud Map to say, hey, Cloud Map, tell me where is the current IP address of that service right now. And Cloud Map will give you the IP address, and so you can make the call. The second one, if you don't want to use AWS-specific API or AWS-specific code inside your code, is just to rely on DNS. And we have 2 different types of DNS, private to your cluster, or public, and using a public DNS infrastructure. And the idea would be just to say, hey, DNS, tell me the IP address of microservice1.mycompany.com, just like you are doing today for website. Cloud Map will maintain the DNS entries and will update the DNS entries as containers are being created or deleted in the cloud for you. So AWS Cloud Map has been introduced in November at reInvent. It's available right now. You can test it right now. My favorite, build, release, and run. Never give a Word document to your operation team saying, hey, you need to unzip this, you need to copy that, FTP that, and then deploy that. That's a thing from the past, from last century. Build and deployment must be fully automatic, and that's the only way to be peaceful at night and to not wake up at 3 a.m. with nightmares or with your pager going in. Try to automate everything. Automate the infrastructure creation itself, but automate the build as well, and automate the deployment. So you take your binaries, you take your configuration, and you create a release that you can push in a container registry, or that's when it's a specific release. So you have the image of the URL, you have the hardware settings of your Docker container, like how much CPU, how much memory do you need, and the environment variable, that's the configuration. And that task definition is the unit of deployment to the different version of your cluster. You can deploy that specific version to your production cluster, to your development cluster, or to your test cluster. You can even create a cluster temporary just to make a couple of tests. The way to automate that, it's using a service called AWS Code Deploy. And Code Deploy, it's, as the name implies, it's a service that will automatically deploy your code for you on your cluster. So it will take a script and will go through your script to deploy your code to either EC2 instance, either to Fargate using ECS and serverless type of services. One of the cool things about Code Deploy is that by default, it does a rolling upgrade deployment. So let's say you have 2 containers rolling, you are starting a new version of your service, so it will create 2 new containers with the new version, wait for this version to be registered to your load balancer and to be healthy, and as soon as they are healthy, then the cluster will kill the old version. So it's a replacement. I bring the new version, I wait for that new version to be healthy and start to answer customer requests, and then the cluster shut down the old version. That's the default update for our deployment type for Code Deploy. But Code Deploy can do something much more fancy as well. Code Deploy can do blue-green deployment. And with blue-green deployment, the idea is to start a new version of your container, to create a new load balancer, or at least a new listener on your load balancer, to direct portion of the traffic to that new version, and to give you the occasion to test that new version with a subset of your customer or with tester, depending on your policies. And only when you think that everything goes well on the new version, then we are going to shift the production traffic to the new version, and we are going to kill the old version. Let's see that graphically how it works. Here we have the application load balancer that listens on port 80 and send the traffic to a first target group made of your old version of your application, the first group of your containers. We call that the blue task. With blue-green deployment, code deploy will automatically create a new listener on the load balancer and on a different port, like 900, and a new target groups. And then it will start to create a couple of containers and register these containers to the new target group. So at that moment, you have two different URL. You have your website /80 and your web address colon 80, the default one, and colon 9000. So you can distribute these two URL among your tester or your customer base and direct some customer to the new version, some customer to the old version. At that time, you monitor what's happening on the new version as well. So you must have your monitoring dashboard, your alerts that are in place. And let's say that you have 10% of the traffic there. If everything goes well, code deploy will then shift the rest of the traffic, 100% of the traffic on the new version. And once all the connections have been drained, so when there is no more customer connection using the old version, it will just kill the old version of your container. That's the blue task. So that's blue-green deployment, and you can do that automatically using AWS code deploy. Another best practice is beware of the version number when you are building your Docker container. If you are using Docker, and I'm doing that a lot, when I'm building an image, I'm pushing the image to a repository, and I'm using a tag. You know the tags in Docker, and you use the tag called latest. That's not a great idea when using a cluster. Imagine that you have your microservice or your application tagged as latest, and then you have ECS that has a couple of versions of your container, and then you have a scaling event. Scaling means we are going to add more container. As long as you are not publishing a new version, everything goes well. But imagine that you publish a new version. So now you have in your repository version 1 and version 2, and version 2 is latest. At that moment, your cluster has a scaling constraint. There is more traffic on your service, so the cluster needs to create more instance of your container. And your cluster has been configured to create latest instance of your container. So the cluster will do exactly that. It will create new containers using the latest tag, except that latest now is version 2. It's not version 1 anymore. Yep. So you will end up in a cluster with a mix of version 1 and version 2, which most of the time leads to some interesting problem to debug, at least. So the recommendation here is to use immutable tags, tags that are very specific to your version number. It might be an SHA checksum, for example, about the image itself, or it might be the build ID, if the build ID are unique between different builds. The way you can do that, you can use the build, you can use the build ID inside AWS code build, or you can use Docker inspect. That was the command I was looking for, Docker inspect, to get the SHA version of your specific container. And if you do that, when you have your version 1, your tag will not be latest. It will be some SHA-256 checksum of your container. If your developer are pushing a version 2, then it will have a different tag. And when the cluster will need to scale out, it will just create more version 1 as expected. So you are not going to mix and match version 2 and version 1 inside your cluster. What about state? Containers are great when there is no state. Ideally, application must be as stateless as possible because it allows to scale very well and to replace instance. But you know that sometimes we are obliged to keep a state. Most applications have a state. So don't keep any state on your Docker volume itself, because the Docker volumes most of the time are attached to the machine where the Docker container is actually running. And if that container terminates and is restarted on another machine, it will not find whatever file it has created over there. So if you have state, use a third-party store, like a database. I know we don't like to use database, but we still have to. And we have a couple of options on AWS to run database or store. It goes from simple file like Amazon S3 for media files, for example. Elasticsearch if you have to index a large quantity of document. DynamoDB, NoSQL. We have a graph database. We have a ledger database. We have a wide variety of relational database with Oracle, Microsoft, MySQL, MariaDB, Postgres. You choose the one which is valid for your application. Port binding, another area where we need some help. You know that a Docker container can expose a port, like port 80, I'm a web server, all great, and then suddenly you need to start 2 instances of a Docker container on one single machine or virtual machine. You cannot have 2 instances running on port 80. So Docker comes with a handy solution for that. It dynamically generates port number, great, but how do I forward the traffic to a dynamically generated port number? I need some kind of intelligence to register whatever port number has been generated by Docker so that my customer can find the port, and the IP address and the port for my service. So we do that automatically for you if you are using ECS and the load balancer. The load balancer has that interesting concept called a target group. And whenever the cluster will start a container, it will fetch the dynamic number, the dynamic port number assigned by Docker and register that number to the load balancer automatically. So you have absolutely nothing to do. That's fully automatic. Your load balancer will know how to reach out to your different containers. How can you maintain developer and production and test parity? If you are not using Fargate, you have EC2 instances. If you have EC2 instance, they must be all the same across all your different environments. Try to resist to the tempting fact of doing an SSH connection to an EC2 server and update a specific library because you have a bug. If you do that, that server will be unique. It will be what we call a snowflake server. You know, snowflakes, they all look the same from distance, but if you look really closely, they are all different. You don't want to have snowflake server. You want all your server to be the same in your infrastructure. So always generate your infrastructure, your server using code. And then, on top of that infrastructure, you deploy your container. We have a couple of options on AWS to generate infrastructure as code. One of them is the old service called AWS CloudFormation. CloudFormation is one of the first AWS service 10 years ago that allows you to describe your infrastructure in a JSON file. So you describe your infrastructure as text. So it can be in Git. You can have your data center in Git, and you can version control your data center. Then you give that JSON file to CloudFormation, and it will create the infrastructure for you. Great, except that CloudFormation, it's like the assembly language of the cloud. It's very low level. It's very close to our API. So it's like 150 lines of code just to create a network. So you need to write a lot of code. You end up copy-pasting a lot and reusing snippets from our documentation or from your library to create code. So today we have higher-level tools that allows you to create infrastructure as code with much less code on your site. And one of them is the Cloud Development Kit, CDK. CDK is in preview right now. Preview means that you can test it, but it might change a bit. So if you're writing a lot of CDK code, beware that the API, the exact syntax might change a bit in the future as we are collecting feedback from you guys. But if you want to try it and give us feedback. So the idea of a CDK, it's a set of libraries in JavaScript or TypeScript, in Java, in C#, maybe later in other programming language, that allows you to give you super high-level construct to generate your infrastructure in the cloud. And when you execute a CDK application, Behind the scene, it's generating CloudFormation templates. So we are not reinventing the wheel or bypassing CloudFormation. It's just a much higher level of abstraction to write your CloudFormation template. For example, to create an ECS cluster, you first need to create a VPC, and you can create a VPC with just one line of code. VPC equal new EC2 VPC network. You give a name and the number of availability zone. And this single line of code will create your VPC with private subnet, public subnet, routing table, NAT gateway. All the best practice that we recommend in terms of networking will be applied by default. So you don't have to choose saying, how am I going to split my subnets, my AZ, should I attach a NAT gateway or not? No, we do apply some default for you based on the best practice that we learned from you over the years. If you want to create an ECS cluster inside that VPC, you just say new ECS cluster inside that VPC. If you want to create a service inside that cluster, so a load balancer and a set of container tasks, you just create an ECS load balance Fargate service or ECS service inside that cluster using that specific Docker image. And that's it. You have roughly 20 lines of code that will generate more than 400 lines of CloudFormation template for you. So give it a try. If you are serious about infrastructure on AWS, never do infrastructure as click in the console, click, click, click. Always do infrastructure as code, IAC, through CDK or CloudFormation or other tools, Terraforms or others. How much time do I have? 20 minutes. So let's finish with the logs, and then let's go to a demo and show you that in real life. Logs. If you have dozens of EC2 instances, hundreds of containers that are starting, stopped everywhere, you can obviously not rely on the host to store the log. You cannot have your Docker container writing to the local disk to store the log. You need your Docker container to push the log to somewhere else, a shared repository where you can aggregate all the logs, where you can search, where you can exploit the log in an easy way. So by default, Docker containers are writing to std out, and Docker has a very fancy mechanism called a log driver that allows to capture what's happening inside a container and push that to a log server. And it does support many different logs like open source FluentD, but we also support AWS CloudWatch log. CloudWatch log is a central service inside the region that you are using that can collect the logs from many different sources. You can search these logs, you can run queries, you can do a lot of visualization or queries with Athena, for example, on these logs. So how to use AWS logs? The cluster does that by default. We generate inside the task definition an entry that says, hey, the log driver for this container will be AWS logs, and then you can configure in which region, what is the log group, and what is the stream prefix that you want to use. Don't forget to add permission to your container to be able to push the logs to CloudWatch logs. So there is one line to add in the permission. The console will do that for you if you're using the wizard, but your Docker container needs to have permissions, of course, to write logs. The other nice things about logs, if you go into the cluster console by itself, there is a log tab where you can see all the logs from all the containers for the service. So all the logs are also aggregated inside the ECS console by itself. You do not need to go separately to CloudWatch logs and to start to filter out across your many different log streams. So that was a couple of best practice about logging, about infrastructure as code, about task definition. Let's see that in real life, how it works. So here I have, in a minute, okay. Here I am in the EC2 console. Let's make that bigger so that at the end of the room you can see. I have one cluster running inside a VPC. It has a funny name because it has been generated automatically by code, by the CDK code that you saw on the screen just before. And the key point here is the task definition. So a task definition is really the unit that allows you to run a container into the cloud. This is where you are going to give us the Docker image, the hardware characteristic of the Docker environment you want to use, but also the environment variable. The first thing you need to do is to tell us if you want to run that without server, Fargate, or with server on EC2. You give a name to your task. You need a permission. What are the permissions that will be applied at runtime, and what network? Then you give the hardware. I want 2 GB of memory and 1 virtual CPU. And I will use this container image where you give a name, the repository URL, maybe some hard-coded port mapping, health checks, environment. And environment, this is where you can say, hey, my DB password is either there, but it's not super secure, because anyone having access to the console can see your secret. Or you can just select a value from and give the ARN, so the Amazon resource notation for a secret in Secret Manager. So I did that for you already, and I have here 2 tasks. One is Nginx with a secret, and one Nginx normal. So the one with a secret has exactly that task definition, saying, hey, there is an environment variable called secret, and the secret will come from ARN, AWS Secrets Manager, blah, 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 my secret. So let's have a look at Secret Manager. I have my secret there. This is where you can define how your secret is encrypted. This is where you can define the key policies and the rotation on the keys to keep your secret secure. And this is also where you can retrieve the secret value. So my secret key is, this is my secret value 123, very secret. You can edit that if you have enough permission. So let's say my secret value, Brussels, and what time is it? It's 2:52, and save this. So this is the new value for my secret. So that task definition that I have here will inject in the environment variable called secret the value of that secret manager. And the Docker container I'm using for this demo does this. So it's a simple Nginx with a website. And at startup time, I'm just creating a file saying, hey, my secret is, and I'm using the variable, the environment variable secret. And I'm storing that there so I can show you that actually it's fetching that value at runtime. And that way you do not need to embed any type of secret, neither in your cluster configuration, neither inside your Docker container. So let's run this task, run task. So it will ask us, where do you want to run that task, Fargate or EC2? In which network? Let's choose that one. In which subnet? I want to access my Docker container for this demo, so I will run it in a public subnet. So I'm asking to receive a public IP address, of course, if I want to connect to that Docker container. And I need to define a security group. A security group, it's like a firewall. It's the set of networking filter rules that defines what kind of traffic can go inside your Docker container. I will select an existing one, which allows HTTP traffic on port 80. So let's run that task. In my cluster, you can see that I have 2 running tasks from a previous demo. And right now, it's also starting provisioning a task for Nginx secret 1. So the provisioning will take a few seconds, and now it's running. If I'm going to the task definition, I will find the IP address that that container receives. If you are really fast and you use mobile phone, you can use the same IP address to test to connect to there. And if you connect to that, you have a very basic website, nothing funky there. But if I use the /secret.txt, so I'm asking to deliver the secret So /secret.txt, you can see my secret is my secret key, this is my secret value, Brussels. So at runtime, the Docker container was able to ask secret manager, hey, give me the value of that specific password and apply that to my container. Once again, the interest is to not share your password inside the cluster definition, so the people managing the cluster cannot see them, and of course the people building the containers cannot see them neither. The developer have no access to that. So that was the first demo I wanted to show you, how to create a task definition, how a task definition can get a secret, and how you can schedule a specific task on your cluster. So task by task, it's great, but most of the time you want something a bit more complicated than just a single task. And that's why we have the concept of a service. So a service is a collection of Docker containers that have a public entry point and that are registered to a load balancer. So when you create a service, there is a load balancer there. And you might have multiple Docker containers. And the cluster will manage this Docker container for you. So for example, here you see the load balancing part, you see the subnet part, you see the tasks that are part of that service. I have 2 tasks. If I'm killing one task, the cluster will automatically replace that task for me. So let's go to the task in the cluster. I can kill my secret, and let's kill another one. So now I have only one container running. And in a few seconds, which looks terribly long when I'm doing that demo in front of an audience, but within a matter of seconds, really, the cluster will detect, hey, you told me that you need to have 2 containers running for that specific task. There is only one now, so it will automatically restart a new container and register that container to the load balancer to start to send traffic to that new container. While it's doing that, let's go to see the load balancer. The load balancer, as you know, is hidden under the EC2 console. So I think there is a link here. There is a link to the security group, the target group, sorry. So in the target group, you can see the different targets. Right now, there is only one, which is healthy. And in a few seconds, there will be a second one that will be added over there. Let's test that application. For that, I need the URL of the load balancer. So I'm going to copy-paste the DNS name of my load balancer here. And I have the same application there. The last thing I would like to demo is how to change that. I told you about code deploy, which is the service that allows you to deploy automatically change. But to have code deploy to work effectively, you need also a pipeline. So a pipeline is like a workflow that will trigger when you change something in your source code, will run the build for you, and will run the deployment for you. So here I have a very simple deployment pipeline with a source on GitHub. So this demo, it's the Docker file and the code is just hosted here on my GitHub repository. We have a build phase that will actually build the container for us, and a deploy phase that will deploy the container for us. So let's change something in my app. I will change something in the HTML file so it's visible. What can we change? We can change, instead of having header 1, header 2, header 3, let's just have 1, 2, 3 as title. Maybe I should make this bigger so that you can follow as well. I don't need this. So header 3. So I made a change in my index.html. I will git add that change. I will commit that change and push that change to my Git repo. So the 3 commands here are git add, git commit, git pull. Let's arrive to my Git repo, and you can see that something has been changed now 11 seconds ago. So it's really a deployment that just happened now. If I'm going back to my pipeline, you can see that the pipeline has detected change just now and has transitioned to a build. And the build is super easy. You define the build script. So in my project, I have a build file that defines the various commands I want to do for the build. In my case, the most important one is docker build, docker tag, and docker push to push the image to my repository. So this is happening in the cloud right now. You can follow the progress, of course, in code build. and see the log file of all these commands that are running there. And it looks like it's finished. The build is finished. It succeeded. Cool. So if we go back to pipeline, pipeline will realize that the build is finished in a few seconds, and we'll go to the next phase, which is deploy. Come on. Let's go back to my cluster in that time. Remember, I was waiting the cluster to start a new task. This task hopefully has been started now. Yes, not only my replacement task has been started, but you see that the deployment is starting as well. So my build creates a new task definition, because task definitions are immutable. I have a new container image, so it's a new task definition, version 21. It's creating 2 instances of that container on my cluster. It's provisioning right now. If I refresh, I guess it will be running, pending first, and then running in a few seconds. As soon as they will be running, my application will accept traffic for the old version and the new version. So if I reload this page, I should eventually start to see some requests with 1, 2, 3, and some other requests with header 1, header 2, header 3. But for that, I need to wait for my 2 other containers to be running. Yes, they are running. So depending, yeah, now you have 1, 2, 3, that's the new version. I reload, it's the old version. I reload, it's the new version, and so on. So what the cluster is doing right now, it's draining connection to the old application. So it's waiting to all TCP connection to finish on the old version of the application. And as soon as all these TCP connections are finished, it will terminate version 20 of my Nginx container. And I will have only 2 containers running, 2 tasks running again, and all my requests will be served by the new version of the application. That process can take a few minutes. Yeah, now it's done. It's only 21. There is no more 20 there. So that's a roll-up. And if I really reload now, I only have the new version. I don't have the old version. I'm reloading as much as I can. So that was the second thing I wanted to show you today. It's how you can actually automate your process of building and deploying to the cloud using AWS Code Commit, Code Deploy, Code Pipeline to coordinate all that. My pipeline here was super simple: change source, build, deploy. Of course, it can be much more complicated than that. Deploy to test before going to production, have manual approval before going to the next phase. You make it as complex or as simple as you want. I hope I inspire you a bit and that you want to try to test or to adopt one of these few best practices in your development. Do not hesitate to reach out to us on Twitter, Sebsto, SEBSTO, and I will stay around a while. If you have a question, I can take a couple of questions offline after this. Thank you very much.